ID number 1042, an IoT-based environment pollution monitoring system for the smart city. Fatima Ara.
Good afternoon, honorable ladies and gentlemen. I'm Fatima Ara, postgraduate student of MIST, working under Professor Shofil Alam Khansa, Director and Associate Professor of University of Dhaka. I'd like to present about a study on an IoT-based environment pollution monitoring system for smart city. My paper ID is 1042. What is an environment monitoring system? An environment monitoring system is a system that senses the environment for the variable environmental parameters like concentration of harmful gases, smoke, humidity, temperature, dust particles, noise pollution, etc., and can generate alert when the situation is critical. Okay. Nowadays, environment pollution is a huge problem, and there are many kinds of pollution, and air and sound pollution are considered to be the most serious environmental problem. The environment condition in Bangladesh is not at all conducive to healthy living. Severe air and noise pollution are threatening human health, ecosystem, and the economic growth of Bangladesh. According to the 2021 World Air Quality Report, Dhaka was the second most polluted capital in the world, and it found that the particulate matter in Bangladesh is 15 times the limit set by the World Health Organization. Here we can see the statistics. In Dhaka, the sound quality is 60 decibel to 100 decibel. According to WHO, 60 decibel sound could make the man deaf temporarily, and 100 decibel sound can cause the complete deafness. It's required half of the pollution of Dhaka city can lose 30% of the hearing power. And so I think it is required to develop a system that can effectively monitor the environment. So IoT is the effective technology for this type of needs. With the help of the monitoring the pollutants in real time can take a preventive measure which gradually help in controlling the environment pollution in Bangladesh. The objective of the study is to design a portable IoT-based environment monitoring system in order to understand the quality of environment, especially air and sound, and to design a web application interface to store, analyze, and present the collected data. The components, hardware components are there, and the software components, and the program language uses in the system. The architecture of the proposed system can be divided in 4 departments: sensor layer, gateway layer, service layer, and application layer. Okay, sensing layer consists of the sensor node for monitoring the environment. The various sensor for collecting the data on gas concentration, temperature, humidity, noise level, and dust sensor are implemented here. The gateway layer, the layer is consists of connectivity components, provides internet connectivity to the system. This layer, the data is transmitted through the internet, and it is protected using encryption techniques. The service layer consists of the server, cloud server, and data storage. The processing of the data is done here, and the data is permanently stored in the cloud. And the application layer provides the interface to the system. User can monitor and control the system in using this interface. The application are developed for PCs and smartphones. Here the list of the sensor. And this block diagram, in the sensor layer, we're using 4 sensor, the HT11 sensor for humidity and temperature sensor, MQ135 gas sensor, and GP2Y1010AU0F dust sensor, and LM393 sound sensor. They are all connected to a microcontroller. It's Arduino Mega. The GSM module is using for the connectivity. Arduino Mega process the collected data by the sensors, and it's sent through the GSM module to the cloud storage. And web interface is developed to graphically and tabular form to represent the data. Here are the methodology. The system allows user to monitor the environment remotely. The overall methodology is sensor node continuously sense the environment. Data is collected by the sensor at present time intervals defined by the duration of sense. Data is passed to gateway device, which filters the data to the IoT server. And data is then uploaded to the IoT cloud, and we can use it for the analysis. And then data is visualized to the user system and indicates a different pollution level. Okay, experimental result is we experimented it in our area. So this is a dashboard which represent the data in a tabular form, and it represents the data in a graphical form, and it indicates whether the environment is good, moderate, or bad in situation. And this is the temperature and humidity graphical representation. The possible outcome is the portable environment monitoring system that will sense the air and sound quality. It's cost effective, user friendly, and the web application can be interface can be used to observe, analyze, and report environment conditional graphically. The first step to achieving a clean, livable environment. Okay, many more sensors can be easily added to the system to make the system further better. The sensor, like we can use a water pollution monitoring system, an ultraviolet radiation monitoring system, and so on. Okay, the IoT-based environment monitoring system, it's actually specifically, you can say, sound and air monitoring system is a real-time monitoring system. This is cost-effective and portable. The system works 24/7, and that allows monitoring the environment from remote location. The system is helpful to conduct research on the collected data, which can eventually lead to have a better and safer environment. Thank you.
Ms. Fatima, thank you for your nice presentation. Are you undergraduate student?
No, sir, my postgraduate.
Postgraduate student. Is the work of your postgraduate research?
Yes.
Okay. Yes. First, have you any question? Okay. I have a question. There are many processing equipment. You have used Arduino Mega.
Right,
Why you use Arduino? Why not others? Now Raspberry Pi is most popular.
Yes, Raspberry Pi is somehow it's costly, and the Arduino Mega is actually integrated with Wi-Fi, and it can be scalable, sir.
For this is you have considered the cost.
Yes, sir.
Okay.
Cost.
Okay. And another.
It's also scalable. Like we can use multiple sensors, and we can add so on, sir.
Okay, I know. You used only very few data.
Yes, sir. I tested it recently, sir.
So
it's just a prototype, sir. We developed it recently, and
okay. So for the research on this purpose, especially for the quality of air and sound, you will get enough data from different sources. Okay, so maybe it will be helpful.
Yes, sir, I think so. Sure, sir.
And since in our
work effectively, sir, actually, that is.
It will be possible.
Yes, sir. Yes, sir.
By your system. Yes, okay, I can understand. Have any other question? Sir. Huh? Sir.
It's a very technical subject. I have not technical subject. I think she proposed a device, software and hardware, to assess the air quality of.
Yes, sir.
So this
Yes, sir.
So you put this device throughout the city.
And they gather the different areas, environmental data.
Definitely they use it. It's required. And,
Yes, sir.
well,
So nowadays,
6 months back,
police.
there was a study done by the other finance from the overseas and some professor of Stanford University.
Okay, sir.
And they proposed that the air quality during the pandemic even in Tesgao area was highest. In Gulistan area, surprisingly, why the Tesgao area is more pollution than the other part of the city? Maybe because of industry. And
Yes,
you know,
sir. The industrial area is
due to vehicle in Gulistan.
increasing vehicles
So,
and urbanization.
during midnight, they discovered that it is the difference between daytime and the midnight pollution is almost no difference.
Yes,
It's
sir.
really a risky.
Yes, sir.
So thank you for the debate proposal.
Thank you, sir. Thank you, sir.
Thank you for the nice feedback. Thank you, Fatima.